Now we're going to do subtraction. This gets a little bit more complicated for various reasons. How would you introduce subtraction? You would typically say things like, this is the opposite of addition. This is the inverse of addition. This is the undo to the do of addition. So yeah, there's a whole bunch of ways you can describe it. And so how would you introduce this to the students to begin with? The takeaway model. Remember, whenever you introduce a new concept to students, you have to always go back to the level where they're comfortable. When I teach my algebra, my calculus, whatever courses, when I teach a new topic, I always make sure that the numbers I use are very small and easy, and then go back to stuff we did in the past. See how they relate. Because once you see a connection, then you can appreciate how it's done. And then we can start building up larger, harder numbers. So the takeaway model, using manipulatives. Should I be bringing manipulative? Y'all want me to bring in manipulative blocks and stuff, or are you okay just thinking about it? It doesn't matter to me. They're just upstairs. Yeah. You want them? All right. So if I'll start bringing those and we start using those. But remember, the more time we use that, we have to hurry up and go through them when we do these examples. Yeah. Oh, yeah. So you have to have a feel for it. I'll start bringing those. All right. So after we get back from the break, I'll bring down and we'll go through the addition, subtraction. We'll go through all these properties using manipulatives. So let me see the numbers I have here. Let's start. Remember, always start off early. So something easy like 8 minus 3. How would you introduce this? Well, you have 8 objects. Those are 8 objects. The subtraction means take away, remove. And you want to get kids upset and make them start crying, give them candy. Say, okay, now we're doing subtraction. You have 10 pieces of candy, and I subtract 10 candy. How much do you have left? Nothing. Get out of here. So no, it's because they always think that you give them a whole bunch of candy, they'll think that's how much they'll have at the end of the class period. No, you'll always end up having maybe 1. So when you take away 3, all we do is remove 3 from this list. And just count what you have left. 1, 2, 3, 4, 5. So that's how you'll introduce the whole concept. Then you get tired of using manipulatives and cleaning up after the students and them either swallowing them or putting up their nose or throwing them to somebody else. You'll get tired of those. So you'll use what? Number lines. Because that's another thing you taught them. Using number lines. These are great because you can print out a whole bunch of them on papers, give them to the students, and have them using crayons go back and forth. Remember, we're only using what kind of numbers here? Whole numbers, which means we start at where? We start at 0. So again, at first you have to remind them, what does 8 mean? 8 means you start at 0 you go to the right because it's positive. How do we know it's positive? There's no negative sign in front of it, no sign in front of it. So this is going to be important because remember, as I said earlier, the signs go with the number. Because this equation here is not really 8 minus 3, it's 8 plus a negative 3. Remember, because we have to make the properties work. In the associative, commutative, distributive, the unity property, all those, we only had multiplication and addition. So we have to try to make everything fit. Subtraction doesn't work in the properties. Is subtraction commutative? It's either yes or no. It can't be. Why not? Why is it not? There's always a why. Eight minus 3, is that the same thing as 3 minus 8?
You get a different answer if you move it around.
Yes, very much, yes. Because if, remember, the property says A plus B equals B plus A. That's the commutative property. But if I have a minus sign, I can't just flip the numbers. Because this is 5 and this is negative 5. Because 8 is bigger than 3. So the only way we can make this work is if we make, again, the number go with, the sign goes with the number. So this is actually 8 plus a negative 3. Now it works. 8 plus negative 3 is the same thing as negative 3 plus 8. Now it is commutative because we know addition is. So we start at 0, go to the 8th place. Because it's positive, positive goes to the right. And since the next sign is negative, that means we go to the left. How many spaces? 3. 1, 2, 3. And there's our answer. We end up at 5 because we went from 0 to 8 and then from 8 down to 5. Eventually, the students will make a connection. Why do we start off at 0? Since we know the first number is a positive 8, why can't I just start right there? Good point. They have to make that connection, not you. Because this number 8 is that number right there, which means that it's 8 numbers to the right of 0. Then from here, I go to the left because it's minus 3. 1, 2, 3. So again, when you teach these to students, you have to make sure that they come up with these ideas, not you. Because it's their discovery, not yours. And you will discover new stuff when you teach. You'll see different ways of seeing things, a lot different ways of seeing things. But you have to have understanding first. That's why if you're going to teach at the elementary school level where all the learning really occurs, learn as much as you can about math. We all know how to read and write. That stuff, we do it all our lives. We take math every year of our life, but we never really pay attention to it. If you think about it, I just told you, we learned this stuff in 5th grade, 4th, 5th grade. We repeat it in junior high. We repeat it in high school. We repeat it in college. Is there a reason why we don't know it? There shouldn't be a reason, except our own laziness. We're too lazy to learn it. Did y'all hear that student in the New England area? She graduated with honors, but cannot read or write. She graduated with honors and she cannot read or write. Why? Because they let her use computers and technology. To read something, she took her cell phone and it read everything to her. When she was typing her paper, she simply had the text to speech or speech to text, and the computer typed it for her. She graduated everything. Somehow she took the test in school and passed. So her mother's school sued the school district. Uh, Try not to fall in the same trap yourselves. Because I know students are notorious for trying to find the shortest shortcuts possible. Don't do it. Okay, the next concept. Oh, first off, let's define subtraction of whole numbers, since we just talked about it. Here's the definition. For any whole numbers A and B such that A is greater than B, A minus B is a unique whole number, C, such that A equals B plus C. So A minus B equals C is only true as if this is true. Also, we talked about closure last time. What does closure mean? What closure means is when we do any operation, first off, before we start, our numbers have to be in that number system we're talking about, whether it's integers, whether it's whole numbers, whether it's rational numbers, or whatever. It has to stay in there. And the answer, both of these are whole numbers. That means our answer has to be a whole number, which means what? C cannot be what? Negative. A and B cannot be negative. So in other words, this is why it's important. A is bigger than B. If A equals B, that's what this says. What if A equals B, what does C equal? 0. Is 0 in the whole numbers? Yeah, it's the very first one. That's why it's called the whole numbers. Now, if A is bigger than B, then this is always going to be true. So we have to make sure that the closure principle always exists as well. Oh, in this equation, in A minus B, A is called diminuend. B is called the subtrahend. How many of you ever heard those words? Minuend, subtrahend. No, because you can only have learned it if your teachers knew it. A lot of times these aren't used anymore. We'll define more terms when we get to the division. We have the quotient, we have the numerator, denominator, we have the remainder, we have all sorts of different terms that we're going to be using. So the bigger number, the first number is the minuend. And the following number minus is a subtrahend. It's subtracted from it. The missing addend model. You notice they're both called minuend and subtrahend. They both have an end to it. Now, how would you go out solving this? How would you teach this to your students? Yeah, remember, you have to start where they're comfortable with first. Before that, manipulatives. Okay, we have manipulatives. They take out three things. That's what they have already. How many more do they have to put inside here to end up with a total of 8? So they keep on adding, putting in there. 3 plus, that's 3, 4, 5, 6, 7, 8. Once they get that, they stop and they count these, so those equal 5. And then from there, you start going further, as you're looking at subtraction. We know that 3 plus some number equals 8. So if we take away 3 from both sides, we have what we're looking for. 8 minus 3 is 5. Same thing. We can use, now we can use the number line, and we can use, but we have to first give them the concept they need first. So that's if it exists. Another tool that you'll see, the fact family. A group of related facts using the same numbers. And it works for these operations. Divisions is a different animal. We'll have to worry about that later. So using this, a family fact would be something like this. If your numbers are all small, then you have to use something, a plus, to get it bigger. Plus makes things bigger, minus makes things smaller. So if we go 5 plus 7, that equals 12. If we go 7 plus 5, that equals 12. If we do 12 minus 7, that equals 5. 12 minus 5 equals 7. That's what a family fact is all about. So it's always going to be true as long as you have those same numbers. So it's either going to be a plus or minus in that direction. Actually, we can do the same thing with multiplication. Instead of addition subtraction, we use multiplication division. Two times 3 equals 6. 3 times 2 equals 6. 6 divided by 2 equals 3. 6 divided by 3 equals 2. Now the comparison model. It's where you compare the two sets of numbers and see how they're different. Because remember, subtraction means what? What's the word that defines subtraction? Use the word different. Actually, that's what we'll also do next week, maybe next classmate, is go through the different words we use in mathematics, just for the symbols. You'd be surprised how many different words there are that mean these four basic signs. So typically we use the difference. When we say 8 minus 3, we're saying, what is the difference between 8 and 3? That's what that says. The question would be, what is the difference between 8 and 3? So we would take out 8 blocks. Then take out 3 more blocks, different colors. So since these are the same, they're gone. What I have left is the difference. Which so far so good. So again, once you start getting the students understanding the concepts of subtraction, again, you treat the signs and numbers differently. Because you notice there's no negative sign anywhere here. I'm only dealing with positive numbers. So it's always 8. The rule is this. Let me show you the rule. Addition. If the signs are the same, take the common sign and add the numbers. If the signs are the same, take the common sign and add the numbers. 2 plus 5. Is the answer going to be positive or negative? Positive, because why? What are their signs? Are they both negative or both positive? They're both positive. So we know since they're both positive, the answer is going to be positive. 2 plus 5 is 7. How about negative 3 minus 4? What's the common sign? They're both negatives. So I add the numbers. 3 plus 4 is 7. If it's the same, then it has to be the same as the final answer. Then subtraction. If the signs are different, take the sign of the larger number and subtract larger minus smaller number. 8 minus 3. Is the answer going to be positive or negative? Positive, because 8's bigger than 3 and it's positive. So it's 8 minus 3 is simply 5. 3 minus 5. Yeah, since 5 is bigger than 3, it's negative, so the answer is negative. Then 5 minus 3 is 2. Negative 9 plus 2. Since 9 is bigger than 2, it's negative. The answer is negative. 9 minus 2 is 7. Again, this is why you want to treat the signs and the numbers separately. That's the definition, the difference between addition and subtraction. Here's a model. Equal additions algorithm. Okay. When we dealt with addition and we borrowed numbers, so to 87, we added what? 3. It made it to a 90. So if we added 3 to 7, we have to subtract 3 from the one that's below, which makes it a 60. And add the numbers. So we had to use opposite signs. The same applies in subtraction. Has to use opposite signs. So if we had 255 minus 163, so if we added 5 to this one, we have to subtract 5 from this one, which means we have to borrow 1. So we'll look at this one. We want to add 7 to that one. And then that means we have to subtract 7 from that one. So the same thing is going to happen. We have a problem. So we have 248 minus 170. We can go further if you want, or we can stop there and just do straight up and down. You have to remember this. What's really happening when we do this, this minus sign actually changes what we're doing. Well, let's first figure out what's going to happen. 5 minus 3 is what? 2. Can we do 5 minus 6? No, so we got to borrow 1. 15 minus 6 is 9. So we know we should end up with 92. That's what our answer should equal. So see, now we're going to a problem here, because if you look at this, if we did these two together, we get 78. We've messed up somewhere, because this sign here changes the entire equation. Running out of time. So here's what we're going to do here in this one. This minus sign stays there. Now, since we have to add 7 to this one to make it go up to the next top one, we add 7 to this one. Now, are we really adding 14 to these numbers? Because if we distribute this set negative inside here, what does this number become? Yeah, so we have a positive negative. So it cancels out. So what does this give us? 255 plus 7 is 5 plus 7 is 12. Carry the 1. So it's 262 minus 63 plus 7 is 170. Let's make this one into 200. So we take 170 plus 30, 262 plus 30, 262 plus 30 is 292. 170 plus 30 is 200. Now there's no worry about carrying stuff over, so we're left with 92. So you notice that whenever you do anything with subtraction, make sure you put in parentheses, because that negative in front is going to change what's happening inside there. So since it's the opposite, we have to put the same numbers inside there. Do we have anything different? And typical, I mean, the rest is the same stuff we've been talking about. The breakup, the trade-off, the stuff like that. It's all the same. All right, so that does it for section 3. All right, next time we'll finish up the chapter, do multiplication division.